So we have square roots, cube roots, and other roots. So obviously, or maybe not obviously, but anytime you see a radical with nothing inside, you assume it's a square. Okay, it's always assumed to be a square root, being 2. Okay, so if nothing's in there, it's just going to be a 2 to you. Okay, so square roots are, like, we all understand our perfect squares, and one thing you may want to write on the side of your book, if you're not familiar with it, is that I would probably expect you to know your perfect squares to 15. Okay, so what I mean is 1 squared, 1, 2 squared, 4, 3 squared, 9, etc. I'm going to keep writing them down. Maybe good for you to write these down as well, just so that you kind of have them in mind. Okay. Oh, 9 squared, 81. And the last one, 15 squared, is 225. So right there is your perfect squares 1 through 15. Why that's important for radicals is because we're going to use these to break stuff down. What I mean by that is when we break down radicals, we're trying to break them down to a number. So when you see this right here, square root of 16 is 4. Because radicals, now when you guys go through your math operations, this is very important, so I'll wait after you're done writing. Okay? When solving, let's ask this. When you're solving, like when we're solving an equation, we're not doing that right now, but when you're solving an equation, how do you get rid of addition? What do you do? Subtraction, right? So in math, it's fairly important to know the opposites. You know what I'm saying? So the opposite of plus, just like Logan told me, is minus. Okay? We got multiplication and division. Okay? Well, this, what we're doing today, squaring is the opposite of square rooting. Squaring and square rooting cancel each other. So if I told you, I said, if I wanted to square root x squared, that'd give me just an x. It just make it go away. Does that make sense? So they're opposites. Okay? So that's what we're talking about here. Square rooting 16, well, what's another way to write 16? How else could we write it like I have here? 4 squared. So square root of 4 squared is just 4. Okay, that's all we're doing with radicals. Radicals are the opposite of squaring. Can they all work out nice and easy like that? No. Sometimes there'll be stuff left in. We'll get to that. All right, so let's see. Kind of skip over things sometimes. So, okay, so principal square roots 2. Square roots of non-perfect squares are irrational numbers. So what that means is the stuff that you leave inside is like a 17. 17 can't break down. 17 is what type of number? What's that? Prime number. 17 is a prime number, meaning the only thing that goes into it is 17 and 1. That's what prime means. Okay? All right. Does everybody have this that needs it? Because when I move, the stuff goes away. What I mean is if I hit this, it goes away. Okay? All right. So, there we go. Now it's even working. Look at that. Okay, cube roots. Okay, all numbers, positive and negative. So the difference is, can anybody tell me something that you will square, any number you want, that will get you a negative? Is there anything you can square that will get you a negative? Nope. Well, what do you mean by odd number, Zach? That's okay. You might have the right idea. That's why I asked. You might see in a second. Well, it's a trick question. There's nothing you can square that gets you negative. Negative 3 squared is positive 9. Positive 3 squared is positive 9. 0 squared, that's still 0. That's not a negative. Okay? But when you get to cube root, maybe off of what Zach was saying, that is called an odd root. Odd roots can be negative because now you have one left off. Right? So if I do an odd root, let's just take this for example here, right here, negative 27. Negative 27 is negative 3 times negative 3 times negative 3. 3 of them. Because I go here, that's a positive 9, right? Now a positive times a negative gets me a negative. That's why with cube roots you can have negative answers. because they're odd. Okay, so a quick rule that you may want to jot down, all odd roots can have negative answers. Yes, sir? Yes, your calculator will do that just fine. On your quiz for some of these, I'm not going to let you use calculator in part of it, so make sure that you know that difference. Okay? So, I mean, you can still use a calculator for your finals and all that stuff. I don't want you to always have to plug that into your calculator, especially for like 27. Okay? Oh, cube? I'd probably say just the first 5. So for cube, that's a good point. I'll get to you in the back there just a second here. 2 cubed, 8. 3 cubed, 27. 4 cubed, 64. 5 cubes, 125. Okay, probably those are all you need for the cubes. Yes, sir? You mean all negative, not all odd? Say that one more time. Like you said, all odd roots are negative. All odd can be negative. They can be both. So you can still do cube root of 27. You'll still get 3. Okay, so odds can have negative answers. So, for example, putting a negative in here, that's okay. If I did square root of negative 27, that's not possible. That's what I mean, in terms of negatives can be on the odds. Okay, so remember, I'm not saying that negatives are always odd. They can be. Okay, anything else? If I talk too fast, what I tend to do, just let me know. Okay, so just going through what they have here. So, see, like right here's their example of a positive. Cube root of 1,000 is 10. 10 times 10 times 10 is 1,000. Okay, 3 zeros timesing by 3 tens. Okay, cube root of negative 27 is a negative 3. We can do that now because it's an odd root. Okay, and then the cube root of a non-perfect cube root of 49, it's not on here. Okay, and none of these numbers go into 49, so that we can't do anything, it just stays. So if you're stuck, it just stays. Okay, the most frustrating thing with radicals is when people aren't sure if that's what it should look like. Like some people try their hardest to break that down for 20 minutes, not trust that it can't be broken down. Okay, so just trust yourself. All right, and then other roots. Okay, so the 4th root of 16. So what number times itself 4 times the 16? Well, let's just stay simple here. Okay, is 2 or negative 2. Because if there's pairs, the negative would kick out a positive. I'll show you what I mean here. I know you're probably not staying with me here. I know it's early. Negative 2 times negative 2. These two together equal 4. These two together equal 4. So that gives you a positive 16 when you do negative 2 4 times. Yeah. It depends what root it's asking for. Like, what do you mean? Like, if it was the... Oh, yeah. If it could be evenly distributed, yes. But this one kind of here, 16 is kind of very friendly, but they're not all that simple. But I see what you're saying. Yes, they can all be distributed. And we can talk more if I'm not hearing you right, too. Okay, so what that means is the root 4 of 16, okay, is just going to be 2. We get into solving, we do have to think about positive, negative, but for just radicals, they want you to only think about the positive answer when it comes to the 4th roots and stuff. Okay. Okay, so kind of like what you hear, like you were saying, so now negative 32, the 5th root of that, it's still 2, because we're just adding another 2. 2 times 16 is 32. So it's saying negative 32, so that's going to give us a negative 2. It's a 5th root, so now odds can be negative. Okay, so that's why it's a negative 32. Negative 2 times itself 5 times is what it's asking. That kicks out negative 32. So our answer is negative 2. So follow with me here. Negative 2 times negative 2 is a positive 4. Times a negative 2 is a negative 8. Times a negative 2 is a positive 16. Times a negative 2 is back to a negative 32. Just keeps going back and forth, fighting the positive-negative battle. Go ahead and take a second and try those examples there. Go ahead and try these, see how you do. It says do not use a calculator, so don't use a calculator on these. So just try doing the best you can, and I'll go over here in about 2 minutes after I move the page down. So go ahead and try example 1. If you can't do it, just put can't do or not possible. Those are on there. Yeah. Do the top and the bottom separate. So do like fifth root of 1 and fifth root of 32. Just do them separate. Think about them one at a time. So here, I'll write it like this. All right, so getting a question on those fractions already. I know you hate them. They're back. They'll be here for a while. Okay. All right, so square root of 64. That should be on your list right now. It should be on your page. Okay. Square root of 64 is what? 8. So we should all have 8 here and feel pretty good about it, hopefully. Okay. All right. Negative 64. Can't do it. You can't square root a negative. So this one right here is just not possible. Don't overthink it. Since that's a negative under an even root, remember that's a 2, you can't do it. But we can do this one because it's under an odd. Oh, that's not you. Different one. I know that one. Okay. All right. So what is the cube root of negative 64? Well, I know my answer is going to be negative. What is it? Negative 4. Good. So negative 4 is that one's answer. 64 was on your cube root list we just made. Okay? And then I have right here, when you have a fraction like this, think about it like this. Fifth root of 1 over fifth root of 32. That's how I want you to think of the fractions. You just do the top and the bottom kind of separate. Fifth root of 1 is just 1. You can times 1 forever, right? And you still get 1. So this is just a 1 on top. The fifth root of 32 we just did in the previous example was 2. So the answer is 1/2. So the fifth root of 1 over 32 is 1 over 2. Okay? Again, I have an even and I have a negative. Can't do it. Okay? Not possible. Okay? And the one little tricky here for the last one, it is the last one. It's kind of segued into our next thing. What is the cube root of 125? We did have that on our list. It's 5. So this piece here turns into a 5. So I have a 10 still and I have a 5. What happens to those two? Do you add them or multiply them as the logical guesses? You multiply them. Great. Because you're multiplying 10 times this, so it's just 10 times 5 for 50. Okay? All right, page 2. All right, so here's some practice with your calculator. If you don't have it, you'll have this in your book to refer to. Okay? So using the square root x feature. So your calculator has square root and cube root pretty easy, but after up above that, 4, 5, and 6, you have to do it yourself. Okay, so what you're going to do is you're going to push, like if I want to put this in my calculator and evaluate, I'm going to first hit a 4. So in your calculator, you're going to put a 4, so it's just sitting there. Okay, then you're going to hit math, and you're going to choose the root x symbol, this guy right here. He's going to be on your list of things you can pick. What that does is it smushes the 4 into that spot for you. So you're going to have this, it's going to look like this in your calculator. Some of your calculators adjust it already, and it'll just put it up there. Some of your calculators will have it like this, depending on how old it is. It'll just leave like that, but it'll read it root 4. Okay, that's how you do different roots besides 2 and 3 in your calculator. Okay, then you hit enter, so this one we hit 10,000. Okay, and that should give us 10, I believe. Yeah. Any questions on that process? Suppose you have your calculators. If you don't have your calculator, I can show you later. That's fine. Okay, if you don't have a graphing calculator, try to get one. If you don't think you can get one, I do have a couple apps that will probably work. Okay. All right, let's try example 2 here. So use calculator to determine the exact value. So I'm going to give you about a minute and a half, 2 minutes. Go ahead and just plug these in your calculator. Put the exact value. Okay? Put exact answers. Yeah, you can use that. Use mine just to, that way you can have. Yep. Okay, and then just phones are good fill-ins. Remember, we can't use those on tests, so don't get used to them too much. All right. I'm going to have, just going to kind of jump around here. I'm going to have Davin, you're going to do A. We'll have Lauren do B. Pick on the girls for the first round. Then we'll have Bethan do C. We'll go boys. We'll go Kyle for A. Connor for B. And we'll go Sam for C. Okay. All right. So whenever you're ready, Davin, what did you get for the first one? You guessed 3? It's a great guess. It is 3. Sorry, I didn't notice you didn't have a calculator. That wasn't very nice of me. Okay. And then we went to Lauren. -4 is correct. Good. Remember, it is odd, it's negative, so your answer will be negative, and that's okay. Okay, we'll start picking up the clues and start putting it together. Okay, and then Bethan? Okay, good, and that would just so you know, that's going to be 5, 6. Okay, we're going to put it as 5, 6. Okay. And then example 3A, Kyle, you have that yet? 3.46. Good, these are going to be decimals, so 3.46 or 7, whichever you round it up to. Okay, good. How about B? 0.924. That works for me. I'll put 0.92. And C. Doing it right now? Okay. Everybody just do, Sam. So if I was you, I just would do this and then do ands times 2/5 or 0.4. So do that part I circled first, and then times the 2/5 last. Probably be the easiest. $1.26, yeah. 1.26. Okay, good. All right. We're not going to go through this lesson today because of the technical difficulties and stuff, so we're going to go to this next section, and then we'll call it good. You guys can just do a little bit of practice today, and then tomorrow we'll pick up where we left off, okay? So to finish, though, I do want to talk about the important thing, which is labeling, like knowing what's what. So in radicals, numbers like root 30, 3 root 125, 4th root 15, 6th root, 1 million, are examples of radicals. These are all radicals. Okay? In fact, any expression with the form of some root to a number is called a radical. Okay? The index is a number, this is whatever is inside here. So if I say, what's the index? Well, this one's index is 3. To us, is cube root. Okay? You have your radical sign and then your radican. So if it asks you to, what's the radican? That would be the number inside or what's left inside. Okay? Questions on that labeling there. So index is your root. Radicand is your number inside. Okay? All right. All right, yeah, we're going to do combining radicals and one more example, and we'll call it a day. Okay, so combining radicals. So very important to understand these rules. If I was you right now in your book, if you got a pen or a pencil, I would probably either star this or circle it in some way so that you look at this. I see these mistakes all the time on quizzes and tests. People get confused what you can do, what you can't do with radicals. Okay? Verify the following calculations. Okay? We're going to do it two different ways. Root 9 times root 4, is that equal to 9 times 4 in the radical? Well, let's think about that for a second. What's 9 times 4? 36. What's the square root of 36? Okay. What's the square root of 9? Square root of 4. What's 3 times 2? We're good. That is allowed. That is okay. So when you're multiplying radicals, you multiply the inside. That makes sense? And the next thing I want to say real quick, just getting off base here, if I had 2 root 3 times 3 root 2, how would you attack that? What would you do? Okay, bonus question. What is 2x times 3x? 6x. 6x squared, right? So what you did, correct me if I'm wrong, is you went 2 times 3 and x times x. Is that correct? You do the same thing with radicals. So I would go 2 times 3 is 6. 3 times 2, root 6. You just go piece by piece. Okay? That's how just a little thing you want to throw out there because people miss that too. All right, so then let's look at this one. Root 9 divided by root 4 is the same as root 9 divided by root 4. Okay, this one's not as quickly easy to see. 9 divided by 4 is the same thing as 9 over 4, right? What did I tell you to do with fractions in the last example earlier? You do the what? The top and the bottom. So then what's the square root of 9? 3, square root of 4, 2. So that would be 3 halves. You okay with that? Same thing, square root of 9, square root of 4 is 3 halves. So you can also divide. These are the cans. You can do that. Okay, now for the do not do's, or it won't work. Root 9 plus root 4 is not the same as 9 plus 4 on the inside. So the way I explain this is think like terms. If I put up here x plus y, could you do anything with that? No, because they're different. Same thing here. These are different values. I can't put these together. Okay? This is like they're different, whatever you want to call them. They're not even close to being the same. One's 3 and one's 2. Okay, so, but I can, after I simplify, I can add them now, which is 5. But you'll see, if I put them in the same radical, what's the square root of 13? Well, it's not 5 because we know the square root of 25 is 5. So that's where you see it's not right. Okay, so this and this are not together. They don't work. Okay, same thing with minus. I'm going to get 3 minus 2 equals 1. I'm going to get square root of 5, which is not equal to 1. All right. Okay, so these are the rules. Product and quotients are allowed. Addition, subtractions are not allowed within radicals. It's that simple. Multiplying, dividing, you can do within the radicals. Addition, subtraction, you cannot. Okay? All right. These examples, and that's it. So couple more seconds here. All right. So this one here, state whether the statement's true or false. So just together, just out loud, is this true or false? True. It's multiplying. We're good. 3 times 5 is 15. That is allowed. True. Okay, this one here. Root 30 over root 10 is 3. True or false? Can we divide? What's 3 divided by 10? Is that what they have? True. Okay. 16 plus 9 equals root 16 plus root 9. False. We see the pluses, right? Like, this is a joke, too easy. False. Okay? All right, so what I'd like you guys to do is, on your homework sheet, let's just cut it down just for your practice here. Let's just try to do 1 through 3 today, okay? 1 through 3. We'll pick up the second half tomorrow. I am going to give you, let me see if I taught it all. I did not. We'll have an exit slip tomorrow, okay? We'll have an exit slip tomorrow. Okay, so just go ahead and finish working today for me, and that should be good.